Out in the wild, knowing heights is key. Is that cliff too high to climb? How deep is that ravine? We need to know these things to survive. That's where the theodolite comes in. This tool is like a compass for vertical distances. Theodolite helps us measure heights accurately. This is important for building bridges, roads, and even understanding the lay of the land. Without it, we'd be stuck guessing. The theodolite is a precision instrument. It measures vertical and horizontal angles. We use these angles with some math to figure out heights. Think of it as a telescope with a brain for numbers. Don't be intimidated. Theodolites may look complex, but they're not hard to use with a little practice. We'll break it down step by step. Before we start measuring, let's get to know our tool. The theodolite has a telescope for sighting our target. It sits on a base with leveling screws to make it perfectly horizontal. There are two important scales, the vertical circle and the horizontal circle. These show us the angles. By reading these scales, we get the information we need. First, find a stable, level spot for your theodolite. Spread the tripod legs and make sure it's firmly planted. Now, mount the theodolite on the tripod. Next, we need to level the instrument. Use the leveling screws to adjust the base until the bubble in the level vial is centered. This ensures accurate readings. Section 5. Focusing and leveling clear vision for accurate readings. Look through the telescope. Do you see your target? Use the focusing knob to get a clear image. A blurry target means blurry measurements. Double-check your leveling. The bubble must stay centered, even when you rotate the theodolite. This step is crucial for precise height calculations. Section 6. Taking aim, sighting your target. Now, aim the telescope at the base of your target. Use the vertical and horizontal adjustment knobs to center the crosshairs precisely on the point you want to measure. Take your time and be precise. Any error in aiming will translate to an error in your final height calculation. Section 7. Reading the scales, decoding the numbers. Once you're locked onto your target, it's time to read the angles. Look at the vertical circle. This tells you the angle of elevation from the horizontal to your target. Next, read the horizontal circle. This gives you the angle from a reference point to your target in a horizontal plane. We won't need this for height, but it's useful for other measurements. Section 8. Calculating heights, putting it all together. Now for the math, don't worry, it's not complicated. We'll use trigonometry, specifically the tangent function. Don't know trigonometry? No problem. There are charts and apps for that. Basically, we use the tangent of the vertical angle and the distance from the theodolite to the target to calculate the height. It's like magic, but with numbers. Section 9. Theodolite in action, real-world examples. Let's say we're trying to measure the height of a cliff. We set up our theodolite, level it, and aim at the top of the cliff. The vertical angle reads 30 degrees. We're standing 50 meters away from the cliff base. Using our trusty tangent function, we find that the cliff is approximately 29 meters high. Knowing this information could be the difference between a successful climb and disaster.